3, and it's just properties of log functions and using some of those properties to solve problems involving logs and logarithmic equations, which is the next section. But it's pretty straightforward. So the first thing you may have heard of is called, am I recording? Am I recording? I'm recording. Hey, no, you're not. This is called the change of base formula. Have you seen that before? Change of base formula. And this is how you find the logarithm of something that is not to a common log base or a natural log base. So in general, log base A of x is equal to log base B of x over, oops, can you see that that's a B? Not really. Okay. Log base B of x over log base B of A. Okay? So what that means is this B can be any base you choose it to be. Okay? And so the log of, so for instance, I could write log base 3 of 7 as log base something of 7 over log base something of 3. And down here, it doesn't matter if it's a 2 or a 5 or an 8 or an E or a 10 or anything like that. Okay? And that's how you plug stuff into your calculator, which is not to a base that's on your calculator. I'll do some examples in a minute. Also, which is equivalent to saying that this is also equal to log base 10 of x, right? Because that base can be 10 over log base 10 of a, which can also use natural log, because it doesn't matter what the base is that you use. So for instance, say I want to know what the natural log, or not the natural log, but the log base 3 of 52 is. Okay? Well, I don't know what the log base 3 of 52 is. Like that's saying 3 to some power gives me 52. Who could give me an estimate? Maybe a rough estimate. What's 3 to the third power? 27. What's 3 to the fourth power? 81, right? So this answer has to be somewhere between what two numbers? 3 and 4, right? And so to find out what that number is, I can say log, I could use the base 10 log, or I can use the natural log, okay? Log of 3. So if I take my calculator and I just go log of 52, where's log? Log of 52 divided by log of 3, log of 3, I get 3.596, just what I said. What? Right, that's what I was saying before. You can't do it. Right, that's why I use the same change base one. Okay? I don't think you can. I think maybe like a TI-89 or something would do it, but I don't think this one would do it. Okay, so 3 to the 3.596 power would give you about 52. Okay? Notice that if I use natural log, it should give you exactly the same answer. Okay? Whoops. Does it give you the same answer? Yes. Isn't that amazing? Okay? So it doesn't matter which logarithm you use. It could be base 10 log, it could be natural log. The change of base form is a very useful thing to solve problems with it. Okay? So then we have some log properties, which I didn't feel like writing, so I copied them down and from your book. And these are kind of important properties. The first one says, since a log is basically an exponent, okay? The log of a product is equal to the sum of the logs of those two values. We'll do some examples, okay? So the log base A of u times v is equal to the log base A of u plus the log base A of v. And it works the same way for natural logs. Log of u divided by v is equal to the log. And these kind of like the same as the rules of exponents, right? Is equal to the subtract, what you get when you subtract the individual logs. And then the power property, this sometimes they call rolling the log. Have you heard of that? Rolling the log. And if you're interested in the derivations of these, you could like look them up in the appendix, or you don't care, you just want to know what it's from. So I could take this and put it in front, and it's equivalent to this. And that's a very useful thing to do when you're solving problems, okay? When you're solving for an exponent. So here's, and also one that's not on here that I already kind of talked about it. What's the log of 1 and the natural log of 1? Log of 1, natural log of 1?
0.
Right. So log of 1 equals 0, and the natural log of 1 is also equal to 0, because 10 to the 0 equals 1, and e to the 0 is also equal to 1, right? So the natural log, the log of 1 is also equal to 0. So say, I don't think yet we're doing solving, we're not doing solving equations, but you could use this little, say you know that log of 3 to the x equals y. To the 5. Let's wait to do something like that. Okay? Let's do a different problem. So you'll see something that looks like this. Write the natural log of 6 in terms of natural log of 2 and natural log of 3. Okay? Could you do that? What's 6 equal to? 2 times 3. So I could rewrite this. Natural log of 6 is equal to the natural log of 2 times 3. But using that first rule, I could rewrite this as what? Natural log of 2 plus the natural log of 3. And sometimes they'll say, without a calculator, give you find the answer to this problem. So they'll say, natural log of 2 is equal to this. Natural log of 3 is equal to this. Find the natural log of 6. You know, so you'd have to use that rule and add together those two values. Okay. Then you have things that say expand. And this is using the rules. Expand as the sum of logs or something like that. So if you see something like this, log of 2x cubed y to the 4th, and they want you to expand that using some of the rules of logarithm. So these things are all being multiplied. See that? Okay? And they'll say expand without any exponents. They'll say any Yep. So you do log of 2 plus log of x to the 3rd plus log of y to the 4th. But then what can I do with these exponents? Roll the log, right? So you get log of 2 plus 3 log x plus 4 log what? Because this 2, these are all being multiplied, right? Yeah. So we could separate that 2 from the x. Okay? Questions? Easy enough? And then I'll do a condense, and then I'll do one word problem.
Did they ever ask you to expand like natural log?
Yeah, same thing. You do it the same way. Okay? So let's do this. So condense. So now this is going in the opposite direction. Condense. 2 log x, 2 log x minus 3 log y plus 1/2 log z. Could you do that? How could I rewrite this with an exponent? So I want to go the opposite direction. Log of x squared, and minus is the same as what? It's dividing up, so you're going to, this goes down here, y cubed. I'm doing this all in one step. And plus is the same as, so z to the 1/2 power. What's something raised to the 1/2 power? Square root. So this can be rewritten as x squared square root of z over y cubed. You understand what I just did? Okay, so I'm going backwards from expanding. Yes? Okay. All right, you'll see there's examples in the book, and I'm trying to use this other book that has different examples, so the examples from the book are good. But so then I want to talk about this problem. Let's see if I can put this one in a new page. So on the Richter scale, the magnitude R of an earthquake intensity, so if they say like this is 2.7 on the Richter scale, or 3.7 or 2.8 or something like that, it means that the intensity is given by the magnitude R of earthquake is intensity minus the I sub 0, which is the intensity of it's like minimal intensity over the natural log of 10. Where that comes from, I'm not exactly sure. But write this as a single common logarithmic expression. So how could I rewrite the top? How could I rewrite the top?
ln I divided by
Well, yeah, I think what they do with this, okay, is we're going to use the change of base formula, okay? So I'm going to change this to base 10 log, because this is a 10. This is kind of tricky, so I'm going to write this as log of I over log of what? What's the base down here? E? Yes? Okay. Minus log of I sub 0 over log base 10 of E, right? Log of E, because there's an E down here. I'm using the change of base formula. Over, and you think this seems like I'm making it worse, but I'm not. Log of 10 over log of E, okay? Log of E. I'm using the change of base formula on all three of these things. What happens to all of these log of E's? Because this is over a common denominator. So this, and this all cancel out. See that? And I get that this is equal to log of I minus log of I sub 0 over log of 10. What is the log of 10? Log base 10 of 10. 10 to what power gives you 10? 1. So there's just a 1 down here. And what's log base? How could I rewrite this? Since it's subtraction, I over I 0, like that, right? So what this is this is where they get the Richter scale from. So if you have, right, this is minimal intensity. I guess that's just like there's always some earthquake magnitude if there's no earthquake at all, right? There's some kind of signal going through there. And then, or the minimal earthquake or something like that. And then this, like an earthquake, would be like 10,000 times as strong is what's actually happened. So if I take the natural log of that, I get like 10,000 over 1 or something, and that's where you get those Richter scale numbers, which are like 2.7 and 2.8 and all that kind of stuff. I was in the big earthquake in 1989 in California, when the Bay Bridge broke in half and all that kind of stuff. I was riding my bicycle. I didn't even know there was an earthquake, because I'm like going like this, you know, and all these people came running out of their house, and I put my foot down. They go, "Oh, that was a really big wind," you know, and then they go, "Wind," and I just kept riding. I didn't even think about it. And then I came home, and there are like all these ambulances and fire trucks. It was crazy. It was during the World Series. Did you know that? During the World Series, the San Francisco Giants were, I forget where they were playing, but there was an earthquake during the World Series. It was a huge one. It was like 6.8, I don't know. Okay. Anyway, so you'll have a problem like that. So that's kind of all the homework is. And then your homework on this section is right here. And you can find it. This one right here, page 207. Okay? But the sub will give you this one tomorrow. And so that's all you're working on tomorrow. Some of these could get pretty tricky. I gave her the long solutions to today's homework and tomorrow's, so she can answer some questions for you and answer some questions as you're working. Right? This is on my website. I don't know if you have to write it down or not.